Okay, so we looked at the fluid simulations, now let's look at the smoke and fire simulation. I built a little scene, and here I have a house and a floor. Now, the whole thing has already been provided with a few materials, and I also loaded an HDRI into the background with a bit of exposure. And I would like to get this house to smoke first, and then we're going to burn it down. How does that all work? Well, first of all, the same three types of object as in the fluid simulation are also valid here. That means we have a flow object again, and that's the object from which our particles of the simulation, the gas particles in this case, will flow out of. Then we have the domain. Firstly, the domain is the limitation of the simulation because the computer cannot simulate a complete world, obviously, that wouldn't work. And the domain is actually at the same time our smoke, or in this case, liquid simulations are liquid. So the domain is not just the limit at which the smoke disappears or the place where you do the settings options, but it actually is the object that is being simulated itself. Okay, let's burn down a house, but first we need to make a domain. So we're going to add a cube, we do tab GZ1 and we scale it up about 5 times, something like that. And this should be our domain now. Now we can also press Alt Z and we're going to have our X-ray view here. And now I'm going to turn off our house, go to physics properties, go to fluid, and then go for type flow, flow type smoke. We do flow behavior, and it should not be geometry, but it should be in flow. This is the same as what we did in the liquid simulation, because geometry is sort of a one-time use of particles of a certain kind. Like in this case, for example, the smoke would then take the shape of the geometry. It's kind of like what we did with the liquid simulation, where the liquid became the bottom. Remember that? Well, here the same would happen with the smoke. We don't want that. We want inflow so that it keeps flowing out continuously, and there's a continuous flow from our object into our domain, because that is how realistic smoke would work. Now, of course, we still have to set up our domain, so we go back to fluid, we do type domain, domain type gas, and here we can already see that if we press the spacebar once to go through our timeline, you can actually see something happening, and what we can see is our smoke simulation. Just like with the liquid simulations, you can now also see this small cube here at the bottom right, and this cube represents exactly the same as in the liquid simulation, so it's the voxel size, in other words, the resolution of our simulation. The smaller this cube is, the higher the resolution, or more detailed and realistic our simulation is. However, the more data is created exponentially, and accordingly, the longer it takes for your computer to calculate the whole thing. So we might want to do some subdivision here. So we go to the resolution subdivisions, and we can raise it to 64. Let's do twice as high. And you can see that already the computer is going very slow, but you're also getting a way more realistic simulation as a result. And the same logic applies like in liquid simulation in terms of caching. So if we look at it the first time, it's going to be really slow, but the next time we look at it, it's going to be a lot more fluent because it is cached into memory. And that's really flexible. However, if you change a thing again, the whole thing has to be reloaded. If you have to rearrange something here and then put it back again to get the same result, you have to go back to your resolution subdivision, change that around, and then the new result will be loaded in. Now down here in the cache settings, we can now change our type from replay to modular, so we have different data chunks. Then you can bake parts of your simulation and deal with it that way. This would help if you want to make an extremely realistic Hollywood simulation, for example, and you really want to get all those details. Then it makes sense, but we're not going to do that now. Right now we're just trying things out, so it makes more sense to have the whole thing set to replay like this, because then you can see what you're doing, and same as with the liquid simulation, you can have a time scale and set it to 10, for example, and you can see exactly what happens. The whole thing is just exactly 10 times faster than before. Oh wait, I don't think I mentioned the time scale in the liquid simulation, did I? Honestly, that's so self-explanatory, I don't think I need to explain it more than what it does now. Border collisions are not activated here by default, but we can activate them and then you can already imagine that it collides on the left, right, top, and bottom sides, and somewhere else within our domain or with the edges of our domain behaving accordingly. Now, if you have the border collisions off, there is no collision, and that means that the particles that go outside of our domain are simply deleted. Adaptive domain is a relatively interesting option as well, because if you work with large simulations here, you can only increase the resolution where it's actually relevant and where you can actually see it. But I've never used it myself, and I don't think we're gonna need it now either. Now, to set the way the gas moves, here we have our gas option. We have 3 sliders here now, and the first one is buoyancy density to control the fullness of the gas, so to speak. Then we have the vorticity, which basically means how you measure how turbulent your gas is calculated, so to speak. Basically how turbulent our gas behaves. This is just known as vortex strength, so you can play around with these values and find your own personal optimum. Unfortunately, there's no presets here once again, which means that you could write down your own values if you like it, you can make your own presets, but we basically start the simulation on the standard setting. Now, we're just gonna start here, we'll fill it up to 3, turn the heat up to 5, call it up to 4, to the maximum, and now you can see the whole thing is very, very crude indeed. But now let's apply a little logic. What does the simulation remind you of now? Personally, it reminds me a bit of an explosion. Now we want to backspace over all the values so it reverts to the default, and now we have another option called dissolve. And with dissolve, the smoke will eventually disappear again. You can see that it doesn't go all the way to the top now, but it's getting thinner and thinner as it goes up. And that's just a realistic kind of smoke that you know from the real world. Our simulation also reacts to force fields, and we're going to include one now here. That is, I'm going to include a turbulence in here, and before doing so, we're going to raise and lower the resolution subdivisions again so that the whole thing is recalculated. And now we can see our turbulence happening, which is now sitting here at a magnitude of 20, which is mostly causing a lot of chaos. Now, of course, you have a complete chaos simulation here, but we don't want to keep that as it is. Of course, we can change that again by selecting the domain, and we put it up once, we put it down once. And that said, whenever you see something and expect some change or something special and you're not getting it, just go to the domain, put it up, put it down again, and then the whole thing can be reloaded, and then you get the result that you want. Okay, that's all for setting up the gas, but now of course the question is, how can we shade this thing? Now we go into the render view here, and we can see that we don't see anything at all. It's not really visible. I'm currently on cycles right now, and I can also change the whole thing to Eevee if we rendered the whole thing in real time. But also here in Eevee, we can see we play the whole thing, and even with the caching, we can see with the low frame rates that something is being calculated, but we can't see it in this mode right now. We can switch to the mode for solid view, and then we'll see it. We don't see the whole thing in the rendered view, and that's a pity of course, because we see it in the solid view. It only helps us a moderate amount at this point, but we also want to render the whole thing at the end. And here it is very important that we distinguish between liquid and smoke. With the liquid simulations, we had the mesh option, which we could simply turn on, and then we simply had geometry that we could shade with a surface shader. And also with the volume, but also with a certain surface shader, it just worked that way. Maybe you remember that I said that the domain then became this mesh. In other words, the cube of our domain becomes the geometry, this mesh. And now we can also shade this mesh, just like we did with a liquid simulation. It's very similar. A lot of the things behave the same, only now there's a difference, and the difference is that our smoke simulation has no surface. We only have a volume. So, long story short, we see the whole thing here, and in the viewport we simply have to shade our domain, which in this case is the cube, with a volume shader, and not with a surface shader, because there is no surface. So we delete it, and then we say principled volume, and this is the volume shader. We pop this into the volume, and now we can actually see our smoke in the render. Now the smoke looks somewhat modest now, because we're rendering the whole thing in Eevee. However, Eevee still has many options in the render settings for various effects for the volumetrics. Now first of all, there's start and end here, and that's where the clip starts and ends. This means that if I walk more than 100 meters away from our object, you won't see the smoke anymore. If I'm close enough now, you'll see it again. That's just relatively irrelevant though. If you can't see the smoke, just get a bit closer and you will see it. We still have the tile size here, and if we reduce it, we have a higher resolution. Now I can also set it to 200 for a start, for example, and you can see it's going to be a lot slower now because the computer slows down, and it means that it's actually rendering the more precise smoke, and that's what we want in this case. Then we still have the samples, and we can also put the samples up, and you can see it ultimately leads to our render becoming more realistic. Then we have volumetric lighting, and that is very important. Volumetric shadows are incredibly important as well, and if we add a few more shadows, especially to our volumetric shadows, then we can really see the three-dimensionality of our volume, so to speak. I can now briefly demonstrate the whole thing to you with a light. If I put a point light in our scene, for example, and I just move it up, we can see that the smoke casts shadows on itself and on other objects in the scene, and that's only possible if you go into the render settings here. Now you can set everything up here under the volumetrics tab, and because we are still in Eevee, the whole thing somehow has to be tricked out instead of done right, because that's the motto of Eevee, we just trick around instead of really doing things. If we want an accurate rendering of these volumetrics, then we switch to cycles, because there's no question about that, because no one really wants to render a crass animation with Eevee. It's completely out of the question. If you really want a good smog simulation, you do it in cycles. But you know, if everything works by itself in cycles anyway, I might as well continue in Eevee, because it should stay a bit more interesting for us to look at. We said we want to burn our house. We don't just want to get smoke out of it, we really want to burn it. So for this, we will first go out of our house into the physics properties, and here at flow type, we will not say smoke, but we say fire and smoke. You can also see that we only have fire or liquid here. We already know how liquid works, we already got to know smoke now, which means we'll do fire and smoke first, and then I'll show you what happens if you only use fire, and you'll see what difference that makes. Everything looks like it stays the same, but we can go way down into our domain, and under the fire tab, we now have various settings and options once again. Now we can go into our principal shader and change a few things here. First off, if we change the color here, we can see that we're just completely changing the color of our smoke. The important thing here now is that you understand that our fire is already there, but we just can't see it yet because we haven't set our shaders for it yet. The first thing we do is enter a temperature in our color attribute. That's the same attribute as below, and we can even just copy the whole thing out here and put it here. What happens now when we change the color is the following. We get a kind of separation between the bottom and the top. And if you're now wondering where our object is slightly turning green, but we'll just take the slider up here relatively far down in the middle, and then the whole thing will be colored the way you want it. Now we're gonna look at the density, because I haven't even mentioned that yet. We can generally just adjust the density of our smoke. At the end of the day, everything is simply a value that you can play around with. The only important thing here is that you have your color attribute as temperature, and have chosen your color well, and then the black body intensity. And that's actually the intensity which is responsible for our fire in the end. You should put this to a value that looks good to you. Personally, I think it looks kind of cartoony, like some 5-year-old drew this fire, but if we now take a look at the whole thing in cycles, then I can tell you that it looks much better. With the temperature down here, we can now easily, for example, set it to 2000 for my sake, and you can see that the whole thing is really glowing up now. So there's a really bright and hot fire, and that's how the smoke and fire simulation simulation works in Blender. You now know all the relevant basics, but one important thing that I haven't done yet is just to have fire by itself. So not fire with smoke or smoke by itself, just fire. If we want to do this, we have to change our flow object from smoke to fire to just fire, and then we still have to select our domain again, put the whole thing up and down, and then we've done this all before, and then we run through the simulation once again, and yes, the result is relatively simple. We no longer have any smoke and we just have fire. Now, for example, this is an option that you could choose if you wanted to, for example, animate a matchbox lighting a candle or something like that, and that's something you want to choose if the fire just doesn't emanate as much smoke as it would do. In some situations, that might be very helpful, so you could just play around with that. And that is it, honestly. We're gonna go on to physics simulations, and in the next lecture, I'm going to talk to you about dynamic paint, and I'm really excited for that one. And I hope to see you again in the next lecture.